So I didn't prepare any slides for this because I really did want this to be more of an open discussion. If I don't get a lot of engagement, I'm probably just going to show off some cool ideas that I've had, along with Sarma as another primary person. But I would really love, because there's a lot of things in this space to talk about, and I'd love to kind of get a sense of what people are especially interested in and have questions on or ideas on. So the idea here is like basically the platform today, the way we do multi-threading or parallelism in general is through this somewhat heavyweight abstraction called a worker. You have to put your file, you have to put your stuff in a separate script. You have to use this post message API, which is not super ergonomic, and even stepping back from that, our primary model for doing multi-threaded computation is this message passing model, which is different than, say, a shared memory model or an actor model, maybe, or things like that. So like this is kind of the space of like, how can we get developers to exploit more parallelism in a way that is pleasant to program with and will hopefully encourage them to do more of it. And a lot of this is like new APIs or language features or things like that is kind of the direction. Short recap, because this did confuse me until like 6 months ago, is like, why is it so important to do multi-threading? This isn't like some, like native apps, a lot of the time, if you want to do a network request, that's actually blocking. So of course you have to do it on another thread. In the browser, everything's async. We use promises everywhere. It's great. So maybe we don't need to do multi-threading so much. Well, so the example that's really compelling is that because of how it's not easy to do things off the main thread, a lot of the code patterns you see today are fetch some data, process the data into a series of DOM mutations, apply the DOM mutations. Now, fetching the data doesn't really matter where we do it. To some extent it might, but it's async. It's not going to jank the page, hopefully. Applying the DOM mutations, well, probably that's going to stay in the main thread, because if anything should be on the main thread, it's the thing that updates the UI. There's some ideas of changing that, but I think that's the for now idea. But processing the data, converting from your JSON string or bytes even into a series of DOM mutations, that's the part that people are doing on the main thread today, because that's the clear, easy path, and they probably should not be, right? That's pure computational work that janks the page and causes you to like either have to invent your own scheduler to like batch it up correctly or something like that. It's really hard. So that at least clarified for me. Does anybody else have thoughts about like why we should be doing more multi-threading? Anything like that? I don't know. Another interesting like counterpoint is like, a lot of the phones these days have 2 or 4 cores, and so we should probably be taking advantage of those. But it's not like the future we're promised where there's 128 cores everywhere. So I don't know. Anyway, I kind of talked about what's wrong with workers, why I think they're not good enough. I don't know. Does anybody like programming with workers? It's it's terrible. So I want to just kind of briefly run through some of this, because this is just like brainstorm of ideas of like things in this space. So every time you create a worker right now, you're creating a whole separate new thread, and that's pretty heavyweight if you want to do a lot of them. So a smart developer has to like invent their own worker pool. But what if you're a library developer? Well, now you have a library pool or a worker pool for your library and a worker pool for the other libraries. And every time you try and compose an application out of multiple libraries, now it's like there's no coordination. So this really feels like an area where maybe the platform should be helping. Similarly, in an area I don't understand as much, maybe somebody else here does, like scheduling manager. So people talk about like Apple's Grand Central Dispatch, or just the idea that you can post tasks to some queue and they will get done and scheduled in an intelligent way. Maybe you can give them a priority weighting or something like that. Justin Fagnani has a proposal from BlinkOn 2016 that I've linked to. And I don't really know this area that well, but like, is this something we should be investing in? It seems like a similar kind of coordination problem as the worker pooling I was talking about.
I think one interesting point there.
Yeah, please, please.
One interesting point there is like the native frameworks are Android and iOS, they typically just have effectively a worker pool of one, and then basically everything from there is FIFO, so you can like reason about the application state fairly well. So they don't have incredibly smart scheduling, but it's something that developers can easily reason about.
That's interesting. So you're saying like, I mean, I guess the big takeaway there for me was like a worker pool of one. Like that's not how I usually think about worker pools, but like if you're writing a web application today, that's actually really hard to accomplish. You're going to create a worker for every off main thread task you want.
And like I think like Android originally tried to spin up like have a worker pool based on like Android 3 of how many like cores were available.
Yeah.
And they found that when like developers have typically just a 2-core phone or a 4-core phone, and then like when someone in the wild tried it with an N-core phone, everything just suddenly broke. And that's why Android went back to like effectively like a one worker pool.
Interesting. Yeah. Yeah. Cool. Cool. Yeah. Okay. Bigger picture questions. Like, I don't know. We could probably spend a lot of time on this, but like, our current model with our current model is workers with this kind of very explicit and awkward message passing, but we also have shared array buffer sitting alongside it. So you can actually, when we turn shared array buffer back on, you will be able to directly operate on bytes in a shared fashion, and you have these few texts and things like that. So that's a very different model, and some web developers are kind of trying to take advantage of this. They're like, there's rendering engines that figure out what DOM mutations they want to do in a background thread, put them as a serialized series of bytecode instructions into a shared array buffer, then on the main thread, read out of that shared array buffer and apply those to the DOM. Is that a pattern we should be encouraging? Is that a pattern we should be like making more ergonomic by creating our own idea of instructions? I don't know. I tend to lean towards like DOM mutations should probably be on the main thread, but there's a lot of inertia behind this idea. And just more generally, like, should we be encouraging this idea of shared objects? Like we could create something on top of shared array buffer. There's an old typed objects proposal, which are basically objects in JavaScript that are directly backed by bytes. They're like views onto a shared array buffer, but of a kind of object-oriented-ish nature. Should we be encouraging that program model with actual shared memory as long as it can bottom down at bytes at some point? I see. Okay. Yeah. In case anybody couldn't hear, I think what I got was like worker pooling and a shared memory model don't play that well together because people want this guarantee of forward progress with their worker that's manipulating shared memory. Yeah. And whereas if you have a worker pool, like your stuff could get deprioritized or other stuff could get in front of it in the queue. That makes sense. I don't know if anybody else has seen this blog post from WebKit from, it's probably a while, okay, August 2017. They, or at least one of their engineers, spent a lot of time working through how they could do actual shared memory in JavaScript. They have like this thread thing, and like you can create thread local variables and close over them, and it's very impressive and complex. And I mean, this is basically, but like when we talk about like, the web has this awkward programming model, one of the answers should be, and I kind of went into that a couple bullet points down, should we just do what other programming languages do and actually have like a shared memory model, first class in the language, where you can just close over things and operate on them? Last BlinkOn, I think, we kind of talked about this and we're like, I don't think so, but it at least feels in scope. Another interesting thing is there was a proposal for Parallel.js, and this was mainly like adding methods to arrays that would automatically parallelize. And this died, I think, because the short version of why it died was they wanted to automatically figure out if the function you passed to map was parallelizable, and that's a very hard problem. Like, does it cause side effects, or is it pure, that type of thing? And so that, at least that particular shape doesn't really work. But this idea does have a lot of traction. Like, I link here to plink, which is a .NET version where they just have like async or parallel for and parallel map and parallel whatever. And like I think kind of combined with some of the stuff down here, maybe that's a way of doing things as well. And if we just say message passing is the right way forever, is that a good decision? And if it is, how can we make it more ergonomic? And that's what some of this stuff is. Kind of it's a little bit out of order. Let's so I mean, if you just look at other languages, I think is another important source of inspiration. I don't really want to. Maybe I did specifically create a link for the example code. So let me at least scroll down to that and kind of bring it up on screen. So C# is a language that I am familiar with, and so I was able to find docs for it pretty quickly. But you can see like they have this like fairly simple way of spawning new threads. You create basically a closure. It takes a parameter, and then you're like, oh, I'm going to use this task feature to like start this closure with an argument. And so you can even do it kind of inline, like task.run. Here's a closure, and it's just like console.writelines some stuff. This is an API that like feels like this is a direction we could head. It would certainly encourage developers to write more code off the main thread, but it feels like it also ties into those questions around worker pooling and scheduling and so on. In particular, at least in C#, they specifically tied this task infrastructure. They didn't call it thread, right? Like if you look at the Apple blog post, they have like new thread. The C# says task because they specifically are like, this may run in the same thread, this may run in a worker thread. We're going to figure that out for you. Just make sure your code is parallelism safe, and we'll schedule it. And you can customize the scheduling, and that's also an important thing. But that's basically the idea. RX Kotlin is another example. Surma is particularly excited about that. I don't know anything about Erlang, but I've heard it has a great concurrency model.
So I haven't written a ton of Erlang, but it's basically message passing. And there's nothing shared. You just send data over.
So that's the model. What's the developer experience like?
Yeah. So people love it. I think there's two important things about Erlang that are different to what we have today. I could be wrong, but I think the two things are, number one, passing messages is super blazing fast. Okay. And it's not super blazing fast on the web. And number two, they have pattern matching on the other side. So just doing the dispatch to do the processing is very succinct and nice. And it's really not when you're writing JavaScript. That's my impression.
I think there's also a key difference between how like languages like Erlang and Rust handle these kinds of things and how C# and Kotlin can handle these. Is that C# and Kotlin are running on top of virtual machines that have support for parallelism in them already. You can create a thread in C#, you can create a thread in Java. Whereas those systems, including JavaScript, really prefer the sort of shared nothing. Like when you create a task, you give it all its data up front, and that's it. And that allows it to, I think, be a lot easier to Erlang. You never have to worry about like, databases and stuff. You can't access it.
At a very micro level, like do either of you know if in Erlang you have to write your workers in a separate file?
No.
Same file?
Yeah.
It's fine. So that's like, I think, one of the simplest possible ergonomic improvements. Cool. And yeah, please.
Like not a language exactly, but there's another programming model you're missing, which is like the kind of TensorFlow type thing where you make a graph, you make your objects for the computation in your shared space, like single source file, same memory, and you hand it off to a runner. And you do have like the overhead of passing things in and pulling results out, but it's also like more, I don't know, it just feels more fluent because you've got that fluent space.
Interesting.
So like there's a bunch of stuff in .NET that's the same actually. Like there's some F# extensions for parallelism and stuff.
Interesting.
Yeah.
Okay.
So there's a bunch of effort to make that sort of go away. Yeah, I think we would maybe do that better in the language, but given the constraints we have, like that is a model that can work. So there's an effort at the moment to it's called TensorFlow for Swift. I think we're actually going to do all that in the language and start looking at objects at an object level. It's kind of interesting. I guess another thing that like Python has operator overloading, which we don't, so it can be like really fluent.
I see.
And with meta protocols, blah blah blah. Anyway, just by the way.
Oh yeah.
That seems to be missing.
The takeaway is you want to have operator overloading in JavaScript.
I think I have a section for notes, which I'm sure you're all furiously filling out. So we should definitely add that operator overloading.
So it sucks for many reasons, but the good thing about that is that it gets us away from the second source file problem, and it lets you able to construct something that's more abstract. Like you can actually change the computation model. Like I feel like one of the things that holds this back is anytime you're running JavaScript anywhere, it's got to have that global that it's associated with, and that's what's important about a worker. And that's
interesting.
Yeah. If it were possible to have a version of the function keyword that created a function that did not inherit the global from wherever.
All right, you guys are just teeing this up for me perfectly. Yeah. So yeah, my remaining 2 points are basically about this. Like, first of all, like people are like, oh, we might have to change the language. At least for this session and a lot of my thinking, I want to think about what if we could change the language? What if we could change, the virtual machine? What if we could change anything? What is the ideal developer experience that we could do on the web? And thinking a little less or a little ambitiously, I have been thinking about language changes. Surma and I both, and like we both basically came up with very similar ideas. And I think, that did not. All right. Well, getting a peek at secret Google documents here at BlinkOn. So our idea is basically that there should be some syntax in JavaScript that's like a block, is what we're calling them. And a block is like kind of like a function, but it's also kind of like a string. It's like, here's a bunch of code. This code is separate from the rest of the source file, but is related, like is just easily inline and embeddable. And so one idea is like they're executable, but this code inside here doesn't have any access to the global. It doesn't close over anything, right? And what else? Right. So how do you actually get state into here? And for this one, so he has a longer example, but I think I'm going to switch over to my my doc because I had little ideas there. My idea uses slightly different syntax, and like in particular, so in his version you'd like need these parentheses, and in mine like maybe you don't. I don't know. Anyway, so this worker is like some kind of function that says I'm going to take a block and I'm going to run it in a worker, probably in a thread pool, probably in like some smart scheduling worker, kind of like .NET's task thing that I'm familiar with at least. So this version takes no inputs, right? This is just like it's fetching, it's getting the response, it's pulling, it's doing the post-processing. Now, how do we get inputs into there? Well, so the magic version is like we somehow detect everything you close over and like we copy it. Probably we shouldn't do that. It's very magic and implicit and confusing. We could like say, okay, we don't actually want to produce a worker. We want to produce a function that will run things in a worker, and then we pass arguments to it, right? Like that's, I think, what Itaka was saying. And you could also like do some cleverness so that you could kind of like write the variables that you're closing over here, but then you have to like figure out a way to pull them in. And that's where I'm going, right? Like, and so you can do more cleverness, like where you inject some variable bindings, but we could just introduce some explicit syntax, right? We could just say like, here is, I explicitly, when I call the worker function, I want to pass in the current values of these variables. And that will like, I don't know, something where that will create a binding inside this block for these variables. Exact mechanism to be determined, but to me, this particular type of syntax is pretty close to what I can imagine as the ideal version, at least with our current paradigm of no shared memory. It's like saying, capture these things, clone them or transfer them, run this code that I'm just going to write right here. I have some like longer examples, like with various other features, like here's something that's infinitely yielding you primes. Here's something that uses modules, and so on and so forth.
Like, how do you keep state over there?
It's just a function, so it's a generator.
I'm going to write an inline marker that actually has a global of its own.
Interesting.
I was sort of like along a similar line. I was curious, like how this could these be thought of somewhat like kind of like inline modules that you have this piece of code that from like a JavaScript modules perspective is entirely independent. It can depend on modules, and like when it gets created in the other worker, it's using a global state associated with those modules that's like separate from any other code you're around. So
first of all, we're not sure what the code inside these blocks should be. Like async functions seem like a really good idea. So probably we should allow await inside of them because we're going to need to await to get the result anyway. But like I had the idea of async generators, so you could do this like infinite primes thing, and then like you could do modules so that you could import other libraries without using dynamic import. So we're not sure. But the second point you touched on that I think is interesting is, do we want to have a global in these blocks? Like worklets, at least, we're trying to explicitly tell you don't rely on the global. We're going to spin up 2 of them specifically to defeat your attempts to store state on the global in that way. And at least I feel like maybe that's how we, like, at least for the primary use cases, or at least the ones I've been thinking about, you want to use these kind of as inline one-time computations that don't need to be stateful and keep state around and be re-invoked.
Syntax has a problem with that.
Yeah.
Actually has less to do with the global than it does with other. Like, let's say this thing relies on a VP9 decoder library.
Yeah.
And you install that library. You don't want every time you execute this function to execute the whole decoder library.
Okay.
You don't really want global state, but you want global code.
Right.
And that was what I was kind of getting at with the modules thing. Initialize the modules once, initialize this function inside that environment, and just call that function multiple times.
Oh, I like this. Okay. First of all, this is a really good point that we overlooked. Second of all, there's like a solution here. Like we just like say like there's like a shared module map inside this worker pool or something like that.
Maybe, but what if your function modifies one of the modules?
You can't modify modules.
Yeah, I vaguely recall something from like a discussion about modules, like shared state and unshared state module system.
Yeah, I mean, so a module could expose to you shared state. That is true, but you could not like from the outside change its exports unless it like exposed a function that said like change my exports. So that feels kind of like we're threading the needle there.
I think at some level, this proposal would need to figure out shared state, how it would work.
Yeah. Well, okay. Why?
Well, like you said, the module is going to have some state that it.
Okay. How it would work? Like, what if the answer is just like it's shared? It's as if you had a single worker and like that worker had some stuff in the global, I guess.
Mm-hmm.
Yeah.
Do you want to be able to tear down the worker when it's like not running anymore?
I see. Interesting.
I'm just thinking out loud.
No, it's good. That's good. This is exactly why I want this brainstorm. Is instead of me just like telling you about all my ideas, like you guys like challenge them and stuff.
The one thing that I think we had in the original classes proposal was that block was just a file, and then anything that you exported, you could like poke at and run it, but I don't know if that will fit in with the argument.
So the reason, so yeah, if people may want to check out tasklets, Surma at least tells me they weren't popular in the Wikji.
Yeah,
and at least, I don't know if the reason they weren't popular is the same reason that I didn't like them that much, but the reason I didn't like them that much is because to do like a simple function, you needed to create a function and export it and then call the export. Yeah. Like this idea of treating tasklets as like a single file meant that for like, you know, here he's just like passing it as an argument to this pipe through function, right? That it was a decent amount of setup.
Yeah.
Was that the general feedback on the?
That was some, but I think like.
Another thing Surma said that the feedback is like, why can't you just already do this with workers? Like, why do we need to put this in the platform? I think that's kind of a meta converstion about like, should we make the platform easy to use, or should we just make it forever unergonomic for every developer?
Now that you have an opinion on that.
You use template strings to do, and like you can do template strings to do this stuff.
Yeah, that's another thing is that you could actually do. So what can you do today, like without this block syntax? Well, you could just make this like a function, right? And then you could stringify that function, and then pass it over to the worker and have the worker create a new function using the string and execute it. This is something you can accomplish today. There are multiple libraries that do this. Greenlit and Clooney, I think, are two names. I mean, this has a few problems that indicate to me it would be better to introduce new syntax. One, obviously, the inefficiency of stringifying, parsing it as a string, stringifying, passing over the string, then parsing it as a function. The other is that you get poor IDE integration. There's no way that you can get any static indicator to tools or even to runtime browsers that like, oh, they're using a variable that's out of scope. Like, that's not going to work. So if you had some special syntax that was like, this is a block, this cannot access things implicitly in its scope, that seems like a big win to me. Those are kind of the things that come to mind. Another thing is, yeah, people suggest sometimes just passing the string directly. The problem with that is that then you can't use multi-line strings inside your multi-line string, like the example right here. So that's not good either.
Bumping up a couple of levels, I
Yeah.
guess. One of the main use cases I really think about for parallelism is dealing with things like media rendering and dealing with sensor input.
Yeah.
And these seem to be much more stream oriented, where you have one
Yes.
worklet or thread producing a stream of data that needs to be rendered in a thread. So either you have a bunch of sensors, you want to fuse them together and send a sample or a secret stream of that to you have media loading from MSC, you want to load on one thread and then tell the other thread when the media is ready. So how do these frameworks kind of fit into those?
Yeah, so there's a couple things. So one is we're separately working on transferable streams like very soon, like not speculatively. And Adam gave a talk this morning with some of that. And I mean, no, this is last year's.
Oh, it's last year's.
I-
The name is very similar. So.
Yeah, actually, I have it in another tab. Good. So his example, so the primitive that he was talking about was introducing transferable streams. So here's a worker that like does a bunch of media decoding and re-encoding, and you would just like post message this worker's stream over to the main page, and the main page would like pipe it through this transferred stream, and so it would do all that work off the main thread. And so this is like pretty good in terms of if you know that you're doing a lot of heavy processing and you want to set it up. But his point was like, what we had to do to set this up is kind of terrible. We had to create a worker, we had to put a bunch of code in a separate file, we had to deal with this post message API for passing the streams back and forth, and then we had to like receive the message that said, oh, here's my transferred stream, and pipe through it. And this is like a decent amount of setup. And I feel like there's a lot of synergy because I think Surma's examples in particular are basically using streams. Like, yeah, they are. This is at least he's using the names of the stream APIs. I don't know if he's actually using streams. But the idea, I think, here is that this off-thread function just creates a transform stream for you using basically the same code that Adam did, but inline, right? Like you didn't have to do a bunch of work. So I think there's a lot of synergy there. I don't know if that really answers your question or if you were looking for a more broad.
Shipping transferable streams would probably give us a lot of what we kind of deliver benefits to, and then we could.
Okay, great. Let's do that.
So I don't have any opinions about the JavaScript side of
Interesting.
this, but what's much better with this than with workers is that workers are physical threads, and this is very hard on the C++ side.
Yeah.
I work on task vector in Chrome.
Yeah.
So a worker is a physical thread. If you go in the background, you're still managed by the OS as a physical thread. Whereas this can just, when you mention the pool, we already have that pool in Chrome. So you can send this to us, and then if you're a background thread, we don't even run it. Or with deprioritize somehow. So this is much easier for us to manage and schedule, and when you have 20 tabs, this is much better.
And so to make sure I understand, like, is that just a matter of developer expectations? Like if we introduced a new thing called like new worker 2, and worker 2 happened to use a pool, that would also help?
The problem with the workers right now is that you can use them as a main, essentially never return from them. So you never return control. So we can't put them in a pool because we could steal a worker.
So you'll want to think about the API surface exposed to these things. It shouldn't be the full worker API. Because not just you can not return, but you can do like one of those things I regret. We added a bunch of sync APIs to workers. And so like we actually encourage you to do that sort of thing that basically requires a thread if you're going to get any reasonable user experience or performance out of it. Like sync file system API.
We're still adding sync APIs to it, right? Like I was talking to someone who was saying off-screen canvas was just changed to add a synchronous API on worker threads.
We should have a discussion about that. That's not going to end well.
But so
That is not on my radar.
what about like while true? Like if they just do a while true, how would this? Are you saying we would just like suspend them sometimes?
No, that would be bad. But hopefully, the goal is they would treat those like tasks that go through and return something.
Got it.
I think while true case is fine. You can while true at the top level. I think that is a developer expectation.
Another interesting thing I want to point out is that where was my example? So my infinite primes example, where did it go? Here it is. So the way so there's an example in the HTML spec that continually finds a bigger prime and just post messages to the main thread. And it does this in a worker so that it chews up, 100% of one of your CPU cores. And here's my version using, futuristic idea syntax. It uses this async generator idea or just generator, where you yield. And the nice thing about this is that a yield is in the JavaScript programming model explicitly a pause point. It's saying, okay, I'm not going to do any more. I don't need to do any more work until you ask me for the next thing. So if the person who wants more primes is on a main thread that's being scrolled, they just won't call next until there's idle time, and then the worker will spin back up and continue. So
doesn't that mean that you won't get the second prime until the worker asks for it? Rather, like you're not getting any of the pipelining effects that are presumably the reason that you went for find another thread if you wanted to.
I mean, so pretend I was like mining the next Bitcoin hash or something more expensive. Like, so I see what you're saying, but I think there are cases where you don't need the pipeline.
I imagine you can also have a parameter that would say, like, here is how big a queue of next results you want to maintain.
Exactly.
In steady state and constantly running, and you have that.
And actually, if you use streams instead of async generators,
I don't know. I mean, like maybe streams is great. I don't know if we have like a JavaScript object stream. Like, you just
totally do.
Having some mechanism for pushback of like usually generating results, but you can back it.
That's a good point. No, yeah, because I gave async generators because it's like, oh, that's what my mind jumps to when I'm thinking in JavaScript land. But streams, we already built in like this idea of a queuing strategy where you're like, I would like to have 10 things in the buffer, and so.
I think one of the things, this might be controversial, what I'm about to say, but I'll just say there's two uses of threading, right? There's threading for taking advantage of all the cores on your device, and there's threading for letting you do something potentially expensive in a way that doesn't jank them in, right? It's the latter one that I care considerably more about. In practice, most of the devices that users have don't actually have more than 2 or 4 cores. So actually we're already taking advantage of all the cores between rasterization and all of our like compositing work. There's not much left to spare to JavaScript to do concurrency. But being able to preempt code is really the thing you get, and I think you get that with any of these variants. Just getting it off the main thread lets you preempt it.
Okay.
Do we preempt stuff like ever right now?
I mean, in practice with workers, we do effectively by using OS threads. The OS does the preempting currently.
Yeah,
but
as people were discussing earlier, you ended up with like a million worker threads existing, each using like 2 megabytes or whatever nice it takes. I know that's being made.
That's right. So with like a worker, with one of these things, you can have a worker pool that uses less threads than workers.
And then you
still I imagine this was just one worker thread.
You need at least one thread for what I just
right,
described.
but now you can no longer preempt it. Doing that. Or you lose items from your workers through a lot of things.
You can't preempt between the different things in the worker pool.
Yeah,
but you can preempt it from like you still protect the fact that like the main thread is still responsive. You can like preempt that worker thing. Stop. Right?
If your finger goes down on the screen, sure, you can preempt and do the scroll.
Right, but you can break all of the background threads, and now like you can scroll, but you can't do anything else.
Yep. That's fine.
Yeah, I do other things in my application.
Yeah, but like this is exactly the model that happens on Android and iOS.
Well, and there I think also you couple this like default pool with like, oh, I actually know I'm going to be doing something expensive. Let me explicitly spin up a thread. And
Well, to be clear, this isn't quite the model on Android or iOS, but those are one per application. Whereas we mix like applications together in a way that you know, you can the only person who can do your work on Android is you, basically. Whereas
Right, so this would be shared between, but it's like people like, pulling like feedback APIs and a bunch of stuff that do use like the regular background thread and Android and iOS still. And like,
I mean, that is an interesting question. Should we have, this is getting very speculative, but is like, you could imagine having at least one thread per origin.
Yeah.
That doesn't seem crazy expensive to me. That still gets the benefits that you were looking for, right?
Yeah, similar to the return control.
Right. That's right, yeah.
it's interesting to me, and I want to try and talk to more people about like how much of this is new technology, and we need to be careful when designing the new technology to enable this, and how much of it is just we're resetting developer expectations. Like currently they use workers in this way, and they should use this new technology a different way. I'm not clear on that myself. We're 6 minutes over into your lunch. Should all let you go. The only thing we didn't really cover is that people have proposed writing workers inline in your HTML. I haven't really seen, or at least this feels much less ambitious and fun than some of the other stuff. But if you think this is interesting, I'd love to hear from you why. Cool.